Hello everyone, so here's part 2 of our lesson 3 notes. We're continuing to add and subtract with our radicals. Okay, here's what I would like you guys to do. I would like you guys to pause the video and do example 5A and 5B. So go ahead and do that. Okay, here's what you've got for your 5A and 5B. So 5A should have been really easy because we've actually really done that in the last 4 examples. So notice that they both have the same radical, the square root, and what's underneath the radical is exactly the same. So notice the only difference here is that we have a variable instead of just a number. So as long as it's exactly the same underneath the radical, they are like terms, so you can combine your coefficients. So our coefficients are 5 and 6. I add those, and then remember you keep the base exactly the same. This is also true for B. So our base here is actually xy to the 1/4. So both of the terms have that as their base. So these are considered like terms, and we combine the coefficients. So what's in front of our base. So 3 and -8 is what's in front. So when we combine that, we should get -5. And then remember, we want to take our base and rewrite that. So it's xy to the 1/4. Okay, let's look at C here. So we have 12 times the cube root of 2x to the 5th minus x times cube root of 54x squared. So they both have cube roots, but notice what's underneath the cube roots is not exactly the same. So we are going to simplify if we can here, okay? So there's a 12 out in front. I will keep that. So remember, when we are simplifying, when it's a number or when there's multiple bases, we are going to separate this. So I have the cube root of 2 times the cube root of x to the 5th. Then minus x, and same thing as my second term, I'm going to separate each of my bases that's underneath the radical. Okay, so looking at my first term, well, 2 is not a perfect cube, and there's no perfect cube other than one that gets into it. So I'm actually going to leave my 2 inside that cube root here. So I still have 12 times the cube root of 2. Now, when I do have my variables, I'm actually going to rewrite this in rational exponent form. Remember, I'm going to have x as my base, and then we do the exponent, and it's over our root, okay? Okay, so now I'm going to do the same thing here. So I have minus x. Now, when I look at my 54, okay, 54 is not a perfect cube, but there is a perfect cube that goes into there, okay? So my perfect cube that goes into it is 27. So I'm going to go ahead and do that. I'll just rewrite it like this. And then we have cube root of 27 times cube root of 2. And then here, I'm going to rewrite my radical here. Notice my variable in that rational exponent form. So 2 is my exponent, and then 3 is my root. Okay, so now let's continue to simplify. So notice that for my first term, the x to the 5/3, 3 doesn't go into 5 evenly. Okay, well, that means we're going to have some x's left inside the radical and some that's left outside. So here, how many times that 3 can go into 5 at most is once. So I'm going to have 12x, that's going to be on the outside. Inside the radical is going to be my 2, and then I'm going to have a remainder of 2. That's my leftover, so I have x squared. Now I'm going to simplify my next one. So here, notice cube root of 27 is 3. So I'm going to put that before the x that's already on the outside. And then my cube root of 2, well, that just stays inside. Now, when we look at x to the 2/3, notice 3 can't even go into 2 because it is smaller. So what that really means is that whatever this x squared is, it's going to be left inside the radical. I can't really simplify it more. So that means what I have inside the radical is the 2 and then x squared. Now notice here that the bases are exactly the same, or what's underneath the radical is exactly the same. So that means we can combine the coefficients. So our coefficients is 12x and minus 3x. So when we do 12x minus 3x, that should give us 9x. And remember our base, which is cube root of 2x squared, we must write that again, and then that'll be our final answer. Okay, make sure you watch part 3. Now we're going to get into the multiplying with radicals.